Hello, this will be a demonstration of proposition 12 from book 5 of Euclid's Elements, which says that if any number of magnitudes it be proportional as one of the antecedents is to one of the consequents, so the sum of the antecedents will be to the sum of the consequents. What this is going to look like is we're going to have any series of magnitudes be in proportion. So the example Euclid gives is if we have A is to B, just as C is to D, just as E is to F, so these are all in the same ratio, but this could go on to like G and H and K and L. Point is that we have some number of magnitudes which are proportional. And what we're going to prove is that as one of the antecedents is to one of the consequents, the sum of the antecedents shall be to the sum of the consequence. What that's going to look like with our example is that A is going to be to B, so A is a consequent, A is an antecedent, B is a consequent. Right, so A is the first part of the ratio, B is the second. So A has to be the same ratio that the sum of the antecedents will have to the sum of the consequents. All of the antecedents here are A, C, and E, and all the consequents here are B, D, and F, which means that A has to be the same ratio that A plus C plus E has to B plus D plus F. That's what we're going to prove within this proposition. We begin by taking equal multiples of the antecedents. So we're going to have G, H, and K be equal multiples of A, C, and E. And we're going to have other equal multiples taken of the consequents. So we'll have the magnitudes L, M, and N be equal multiples of B, D, and F respectively. Now, because A is to B, just as C is to D, just as E is to F, we know by definition 5.5 we can say something about their equal multiples. And this is that if G be greater than L, H will be greater than M, and K will also be greater than N. And if G be equal to L, H will be equal to M, and K will be equal to N. And if G be less than L, H will be less than M, and K will be less than N. Which means that let's say we just take one of those, right? So let's take G is greater than L, H is greater than M, and K is greater than N. What we can say from that is that we can actually add all of those together by property of magnitudes and say that G plus H plus K will be greater than L plus M plus N. And likewise if they're equal, and likewise if they're less. But the relationship that this sum has to this sum is contingent upon the relationship that G has to L. And so we can say that if G be greater than L, then G plus H plus K will be greater than L plus M plus N. And also if G be equal to L, G plus H plus K will be equal to L plus M plus N. And finally, if G be less than L, then G plus H then K will be less than L plus M plus N. Now we know that G, H, and K are equal multiples of A, C, and E, right? We did that in the first step, which means that by proposition 5.1, if we have any number of magnitudes and equal multiples be taken of all of them, the multiple that 1 is of 1 will be the multiple that the sum is of the sum. And so the multiple that G is of A will be the same multiple that G plus H plus K is of A plus C plus E, which essentially means that G and G plus H plus K are equal multiples of A and A plus C plus E, respectively. A similar reasoning, we know that L and L plus M plus N are equal multiples of B and B plus D plus F, respectively. But we also had shown that if G be greater than L, G plus H plus K will be greater than L plus M plus N, and if equal, equal, and if less, less. And these right here are equal multiples of A and B, and A plus C plus E, and B plus D plus F, all respectively. We can then say, by definition 5.5, that because the equal multiples are such, A has to E the same ratio that A plus C plus E has to B plus D plus F. This being what we set out to prove, we are done with the proposition, therefore, etc., Q, E, D. I've got nothing, at least unique, nothing extra to say about this proposition, so end the video here and move on to 5.13.